Hello everyone, today we discuss about parametric study of effective depth of beam with slab. First of all, click here new project, space, give the file name parametric study of beam. Units is always in meter and kilonewton. Then next, add beam and then finish. Now this is your grid for your structure. Go to edit. Now take the XZ plane. Okay, now we with the help of snap node beam we take our size of slab. In X direction we take slab in 7 meter. These node are inserted for the beam, placing of beam. In Z direction we take 5 meter. Then now we insert our beam from node to node. Now remove your grid. Now you can see this is your slab with beam. Now you also see the dimension, display your dimensions. Now you can see in Z direction we take 5 and X in we take 7. Then go for general, go to property, click here define property. In parametric study, in first case we take beam size, matlab shape is rectangular, the size of beam. We study on the parametric related to depth of our beam. In first case we take 0.5 depth and width is take 0.25. Then click here add, then close, and then click here thickness. For the slab thickness we take 0.15, add, then close. Before assigning the thickness, first of all we place our plate. Click here add plate. Now click here from node to node we insert our plate or slab. Same as it is we insert our slab. Now assigning the plate thickness. Click here plate thickness, assign to view, assign, yes. Now you can see plate thickness are assigned, and then assign the beam size, assign to view, assign, yes. Now you can see all the property are assigned. Then go for support. In our case we take fixed support. First of all click here create, then add fixed support. Click here, use cursor to assign here, assign. Then place the supports at the corner of your plate. Then click here assigning. Then you can see supports are assigned. Then go for load and definitions. Click here load case detail, then add. In first load we take dead load and give the title of dead load, add. Then second we take live load and give title live load, add, then close. Now in dead load click here add the self width, which is factor is -1 and traction is always y, add and then close. And in live load click here add live load, click here, add live load. Now you can see here different type of load are shown. In our case we take plate load. Take plate load is -3 in GY direction, add, then close. Now assign live load, click here, assign to view, assign, yes. Now you can see live load is assigned. In our case we also take the load combination of dead load and live load. For this combination, go to the load case detail, simply here add. Now you can see, go for define combination, give the name of your load combination. We take load combination factor is 1.5 from IS code 456-2000. Dead load plus live load. Now here you can, your dead load case is shown, add and then close. Now here you can see self weight, live load and load combination. Here you also can see simply dead load, live load and load combination of dead load and live load. You also can see here, you can also see the 3D rendering view of your beam with slabs. You can see all the loads and thickness are assigned. Then go for load supports and load combination are applied, and go for analysis and print. Click here, add, then close. Go for analyze, run analysis, save. Now you can see 0 error, 0 warning and are shown. Then go for post processing mode. Done. All the load are selected, apply, then OK. Now here you can, this is the post processing mode where you can see all the results. This is your reactions, displacement. Forcing displacement, go for labels, scales. You can take 10, apply, OK. Now you can see your displacement. And for seeing the load values, go for labels, click here load values, apply, then OK. Now you can see your load values which we are taken. And now you also see your graphs, all the bending moment, shear forces, stresses and forces are shown. In we go for reports. In this we take our output. Here you can nodal displacement summary. We take nodal displacement summary and beam force detail summary. Okay. Now you can see here your nodal displacement, where your nodal are displaced, beam, where your beam forces are shown. And also we can see our beam displacement summary. Now here, okay. Now this is showing where your beam are displaced. All the factors are shown. Now this is our first case in which we take our depth of beam is 0.5 and then go for modeling. Now we gonna change our parametric, which is depth of our beam. Simply go to the properties and edit here, and we change our depth of beam. Now we are taken, our depth of beam is 0.7. you can see why is that is the depth of beam, and width is also same, is 0.25. always depth of beam is greater than width of beam. Change, yes. Now you can see the properties are here. Assign to view, assign, yes. Now property are assigned. All the loads and plate thickness are same. Simply go to the analysis, add, close, then analyze, run analysis, save. Now you can see error is 0. Go to the post processing mode, done. All the load which we are applied, okay. Now here you can see reactions. Our depth of parameter are changed. Deflection, you can see deflections. Now you can see also reduce the scale, apply, okay. Now you can see your displacement, and go for graphs. This is graphs and stresses. And now we see our result. Go to the reports. Now go to output. Now we check our nodal displacement, beam displacement, okay. Now you can see for changing our depth parameter, all the values are changed for nodal displacement or either beam displacement and beam force. Yes, this go to the beam. Now this is our problem in which we are discuss about parameter changes of beam, which in which we take the depth parameter of beam. With the help of all the results are different. Thank you.